Hi, bacha log, how are you all? Today's topic is midpoint theorem. Actually, midpoint theorem is already started. We have discussed a video where we discussed that what is called midpoint theorem, and we have seen a sum based on midpoint theorem. But in this video, actually, this is the second part of midpoint theorem. If you have missed the first part of midpoint theorem, you must watch that video. Otherwise, you will not be able to understand this video. Okay. The link of that video, the part 1 of midpoint theorem, is there in the description box. Yes, there in the description box. You can see, you can watch that video first. After that, come to this video. Okay. So here in this video, we are going to discuss few difficult sums based on midpoint theorem. So let's start. Okay. First of all, the question is, prove that figure obtained by the joining the midpoints of the adjacent side of a rectangle is a rhombus. My God, try to understand the question. Rectangle we have to draw first, and we have to join the midpoints of the rectangle. Let's see. This is the rectangle. This is the rectangle ABCD. ABCD is the rectangle. Fine. Now we are going to join the midpoints of all the sides. It is the midpoint is say P. P is the midpoint of AD. This is Q. This is R. And this is S. Okay, so P, Q, R, S are the midpoints of all the sides of the rectangle. We are going to join them now. PS we are joining, P, Q, Q, R, R, S. Now what we have to show? We have to show that P, Q, R, S is a rhombus. Okay, it's a rhombus. Now to show that it's a rhombus, just show that all the sides of P, Q, R, S are same. You understood what I said? I said all the sides of P, Q, R, S are same, then it's a rhombus. Like if I can show that PS equal to PQ equal to QR equal to RS, means all the sides are same, so it's a rhombus. So we are going to use midpoint theorem. Okay, let us use midpoint theorem. But before that, I have to draw something extra. I mean, this figure is not enough to show that this is a rhombus. Okay, we have to draw something extra. What is that extra drawing called? Correct, construction. So we have to construct extra things. Construction. What is the construction? Construction we are going to do that we will join BD. Okay, so what is the construction? Construction is join BD. Okay, BD we are joining. Fine. Now I can say that in triangle ADB, can you see this triangle ADB? Yes, in triangle ADB, P is the midpoint of AD, P is the midpoint of AD, and S is the midpoint of AB. Now one thing here, don't give this arrow in your exam paper. In exam paper, you are not allowed to give this arrow. Okay, I'm not writing that. That doesn't mean that you will also not write in the exam. No, not that. Okay, so you have to write P is the midpoint of AD, S is the midpoint of AB. Okay, so we know from midpoint theorem, we have already discussed in the first part of the video. Okay, we have seen that if P is the midpoint of AD and S is the midpoint of AB, then I can say that this PS is half of BD. Okay, PS is half of BD. PS is half of BD. We have seen in the first part of the video. Okay, so this is your first equation. Understood? Now in triangle this one, CDB, this triangle CBD. Okay, CBD. Here Q is the midpoint of CD and R is the midpoint of BC. Don't give this arrow in the exam paper, as I told you. Q is the midpoint of CD and R is the midpoint of BC. So I can say that QR equal to BD by 2. This is your second equation. Okay, this one we have discussed in the first part. That what is midpoint theorem, we discussed there. We discussed this. Okay, hope you understood. So QR is half of BD. Now we will draw another construction. This one. Okay, this one. So here I can say in triangle ABC, I can say that S is the midpoint of AB and R is the midpoint of BC. No, in triangle ABC, this triangle, S is the midpoint of AB, R is the midpoint of BC. So I can say that R is equal to AC by 2 by using midpoint theorem. AC by 2. AC by 2. This is your third. Or now, we'll write R is equal to. Now see, it's a rectangle, right? It's a rectangle. Now in a rectangle, both the diagonals are equal. Yes, just think about a rectangle. In a rectangle, the diagonals are equal. So instead of AC, I can write BD. So I am writing BD. BD by 2. This is my third equation. Now in triangle, take this triangle ADC. ADC. In triangle ADC, P is the midpoint of AD. P is the midpoint of AD. And Q is the midpoint of CD. CD. Okay. So I can say that PQ is AC by 2. PQ is AC by 2. That means PQ is, now instead of AC, I can write BD because the diagonals of a rectangle are equal. So instead of AC, I can write BD. BD by 2. That is equation 4. Okay, equation 4. Now, from all these equations, see, right hand side is BD by 2, BD by 2, BD by 2, BD by 2. All are BD by 2. So all the equations right hand side are equal. That means left hand side will also be equal. Okay, when two equations have equal right hand side, that means their left hand sides are also equal. Okay. Now, so from 1, 2, 3 and 4, from this 4 equation, I can write that PS equal to QR equal to RS equal to PQ. That means PQ, this PQ equal to QR equal to RS equal to PQ. Okay, all these sides are equal. So it's a rhombus. Understood? Let us move to our next sum. Next sum. See, in this sum, it's a trapezium. ABCD is a trapezium. ABCD is a trapezium where CD parallel AB, right? CD parallel AB. Now it is also given that P is the midpoint of AD. Okay, it is given that P is the midpoint of AD and PR is parallel to AB. Understood? Let me tell you again. P is the midpoint of AD. Okay, and PR parallel AB. That much is given. Let me write what is given here. Given is P is the midpoint of AD and PR parallel to AB. That much is given. Okay, and we have to show this. We have to show this one. Understood? PR equal to AB, PR equal to AB plus CD by 2. Okay, but to show this much diagram is not enough for us. Yes, we have to draw something extra. That is called, yes, construction. So let us construct. What is the construction? Construction is join BD. Join BD. Okay, BD we are joining. Now see this triangle. Triangle ADB. In triangle ADB, P is the midpoint of AD. P is the midpoint of AD. Okay, and P say this is M. PM is parallel to AB. That is also given in the question. PM is parallel to AB. Now these two are given. P is the midpoint of AD and PM is parallel to this. These two are given. When these two are given, then I can say that M is the midpoint of DB. Okay, M is the midpoint of DB. So M is the midpoint of DB. I can say that by using midpoint theorem. And also we can say that PM is AB by 2. PM is AB by 2. All this I can write by using midpoint theorem. Okay. Now this is equation number 1. Again, for this triangle BCD. Triangle BCD. In triangle BCD, I can write BCD. R is the midpoint of. No, R is not the midpoint. That is not given. We cannot write that. We cannot write. M is the midpoint of BD. That we can write. M is the midpoint of BD. But M is the midpoint of BD. That is also not given in the question. So from where you are getting it? From here. Here we have shown M is the midpoint of DB. M is the midpoint of DB. This is what I have written here. M is the midpoint of BT. If M is the midpoint of BT and this PM is also parallel to CD, PM is also parallel to CD, so I can write that PM, no, you will write RM. Yes, this RM is parallel to CD, so I can write that R is the midpoint of R is the midpoint of BC. Yes, R is the midpoint of BC, and also I can write that by using midpoint theorem that MR is half of CD. MR is half of CD. CD by 2. This is equation number 2. Okay. These two things are same by using midpoint theorem. Okay. If you have got any doubt from this, then you should watch the first part of midpoint theorem. The link is there in the description box. I already said. Okay. Now to show this, we have to show this. The sum is not finished yet. So equation 1 and equation 2, both the equation will be added now. So 1 plus 2. So 1 plus 2 means left hand side plus left hand side equal to right hand side plus right hand side. So PM plus MR equal to right hand side plus right hand side CD by 2. Okay. PM plus MR is PR. PR equal to, what is the LCM? 2. That is AB plus CD. Yes, proved. That is, yes, proved. Understood? Let us move to our next sum. Next sum. In this sum, ABCD is a parallelogram. ABCD, which you can see in the board, that is a parallelogram. Okay, and L is the midpoint of AB, M is the midpoint of CD. Okay, and what I am doing, I have joined this DL and this MB. That is given in the question. I am not doing that. That is given in the question. Okay, and what I have to show? We have to show that the line joined AC, this AC is trisected. AC is trisected. Trisected means 3 equal parts. Trisected. That is this equal to this equal to this. Okay. If this is say P, this is Q, then AP equal to PQ equal to QC. This is what I have to show. AP equal to PQ equal to QC. This is we have to show. Okay. If this equal to this, I can show that, I can say that yes, this AC is trisected. Trisected means 3 equal parts, divided into 3 equal parts. Okay, so we have to show this. But before showing this, we will try to show that DLBM is a parallelogram. Easily we can show that. Okay, DLBM, this one is a parallelogram. We have to show this. Let us see how do you show that. See, since ABCD is a parallelogram, no, ABCD is a parallelogram, so I can say that opposite sides are equal and parallel. No, opposite sides are equal and parallel. So opposite side means AB equal to CD and AB is parallel to CD. Okay. Now, AB I am dividing by 2 and CD also I am dividing by 2. So I am getting AB by 2 means BL. BL because L is the midpoint of AB. That's why BL. CD by 2 means DM. Okay. CD by 2 is BL. Now also see BL is the part of AB. So from this one I am writing BL is the part of AB, BL, and CD, DM is the part of CD. DM is the part of CD. No, BL is the part of AB and DM is the part of CD. Since these two are parallel, that means these two are also parallel. BL parallel DM. BL parallel DM and BL is also equal to DM. BL is also equal to DM. Now, we know that when opposite sides are equal and parallel, that means that figure is a parallelogram. Yes, this is the condition of parallelogram. Don't forget. If the opposite sides are equal and parallel, then it's a parallelogram. Now here see, opposite sides are equal and parallel. So I can say that DLBM parallelogram. Understood? Any doubt? Try to watch this video. If you are not able to understand this, just rewatch this video. Okay. Then easily you can understand. Simple sum. Now, what I'm doing, we'll take this triangle CDP, in triangle CDP. Okay, CDP I'm taking. In triangle CDP, I can say that M is the midpoint of CD, and QM or MQ parallel to DP. I can say that MQ is parallel to DP. Can you tell me why I have written that? How can I write that these two are parallel? Can you say? Think. Yes. Since this is a parallelogram, I have shown here this is a parallelogram. That means opposite sides are equal. Okay. In a parallelogram, opposite sides are equal. So these are two opposite sides of this parallelogram. So these two are equal. Okay. MQ parallel DP. Fine. Why MQ parallel DP? Because this is a parallelogram. Now, why this is a parallelogram? Because we have already shown it here. Yes, for this only we have shown it first. Okay, so I can write that. Since M is the midpoint of CD, MQ is parallel to DP, so Q is the midpoint of CP. So Q is the midpoint of CP. Understood? Q is the midpoint of CP by using midpoint theorem. So Q is the midpoint of CP. So I can write that since Q is the midpoint of CP, I can write that CQ equal to PQ. CQ equal to PQ. This is my equation 1. Understood? Now, we'll take this triangle. This one, AQB or ABQ, in triangle ABQ. Okay. In triangle ABQ, L is the midpoint of AB, that is given in the question. L is the midpoint of AB, that is given in the question. And this parallel to this, PL parallel QB. Why PL parallel QB? Because this is a parallelogram. Yes, these two sides are parallel. That's why I'm writing PL parallel BQ. Because this is a parallelogram. Here we have shown this. Actually, for this and this line only, I have to show that this is a parallelogram. Okay. Now, just think about this triangle. This triangle. L is the midpoint of AB and PL parallel QB. That means P is the midpoint of AQ. If P is the midpoint of AQ, then I can write AP equal to PQ. Okay. I can write that PQ equal to AP. This is my equation number 2. Okay. Now from 1 and 2, we'll utilize 1 and 2. What we are getting? We'll get in 1 CQ equal to PQ. And in 2 PQ equal to AP. Instead of PQ, I can write AP. That means CQ equal to PQ equal to AP. CQ equal to PQ equal to AP. So this one is proved. Okay, so this line is trisected by these two lines. Understood? So here we discuss few sums. We are going to discuss more sums in the next part of this video. I mean in the third part of the video, midpoint theorem. Okay, so this much for today. Thank you.